And our theme is physics and our project name is Fun with Physics. As we know, there is a lot of interesting events that takes us around us, which makes us to think and get curiosity and ask questions like how and why. And we have selected some physics concepts and we'll explain in easy way and with the help of fun experiments. And we are also connecting some physics concepts to the aerodynamics.
Physics. Physics. Physics covers a huge range of topics like force, motion, etc. etc. Today we are taking up the concept of pressure. And our first experiment name is attracting balloons. By blowing air between them, they are not ready to be apart. Think once what happened to these balloons if I blow the air between them. Obviously, our common sense tells us these balloons move further apart. Then let's find out. These balloons move closer together. Then what is the physics behind this? When we blow the air between the gap of these two balloons, we are creating an area of low pressure. And the higher pressure surrounding these two balloons pushes the balloons towards the pressure. So these two balloons attract each other. And let's move on to second experiment.
This is the experiment of the floating of a ball. As we see in the floating of a ball experiment, the air coming from the air ball is moving much faster than the air around it. So the ball stays within the column of the low pressure because of the high pressure around it. Now let's move on to third experiment. This is also similar to what I have explained now. This is also one more fascinating experiment which is dancing ball. Here water disturbs the existing area, so the ball stays in the low pressure column. And these three experiments relate to the Bernoulli's principle. According to the Bernoulli's principle, as the speed of the fluid increases, pressure decreases. As the speed of the fluid decreases, pressure increases.
And here you can observe another fascinating experiment. Here only 3 matchsticks is holding a 500 ml water bottle. We have not restricted the matchstick to the table nor to the string. Here net force becomes 0 because the table is providing an upward force to the first matchstick and the string, gravity, is providing the downward force to the same matchstick. But the second matchstick is providing a downward force as well as upward force. But this third matchstick is holding second matchstick by providing an upward force. Here 3 upward forces and 3 downward forces. And cancels each other and the bottle stays in the same position. And you can try by removing one stick, it will fall down. Yes ma'am, you can do.
Any matchstick.
Yes ma'am, any matchstick you can remove, it will fall down. Here you can see another same experiment. The weight of hammer would pull the scale off the table. But when the upper is holding the hammer, but the ruler will fall down. When we hammer is only providing an upward force, but the gravity is pulling down. Here, only one upward forces and one downward forces is acting. So here also net force becomes 0. And this is linked to static equilibrium. According to static equilibrium, when 2 or more forces acts on the same body, which is in state of rest or in state of motion, it remains the same. The same concept is happening here. And let's move on to another experiment. Here, you can observe that the single nail is holding the whole bunch of nails. Here, the center of gravity is playing its role because there will be a center for everything, center of gravity. As you can see here, I can hold a stick here, but when I hold this, it will fall down.
The center of mass.
As well, center of gravity, center of mass, same.
No, when you are telling the center of gravity, we are considering weight of the body. When you are telling the center of mass, it is about the mass of the body. So, weight is different, mass is different.
Here the center of mass is acting. As you can see, if we move the leg towards left or towards right, it will fall down. And next, torque. Torque is nothing but rotating force. And here, as you can see, this is called as rotating force. And the center of gravity. Here, as you can see, this can stay here in the. How many times you can keep here, it will stay like this only. And as you can see, when the force is applied on this, it becomes as a torque. And we all, as I said, the Bernoulli's principle, static equilibrium, all are linked to aerodynamics. This aerodynamics explains how an aeroplane is able to fly. Aeroplane is able to fly with its wings. These wings are curved on the top and flattened on the bottom. Those curves make the air traveling over the top faster than the air traveling below it. And aerofoil. Aeroplane wings has a special shape called aerofoil. When the air traveling above this aerofoil, the air will travel further and faster, creating an area of low pressure. And the air traveling below it will travel slower and create an area of high pressure.
Yeah, that's why.
And next, as I said, four forces act on a flight. However, helps to aeroplane to take off. Those are thrust, lift, weight, and drag. And the lift, every aircraft which flies must have a lift. And for an aircraft, it should have more lift than the weight. And next, thrust. Thrust is helpful for an aircraft to move forward. But everything has a drag. Drag is opposite to thrust. Drag is helpful for an aeroplane to slow down. As you can see, as I said, the aeroplane, this is a model, then that is a pictorial representation. And as I said, the air traveling above it will create an area of low pressure, air traveling below it create an area of high pressure. Those differences those pressure differences create an upward force called lift. Here, when the lift occurs, the torque. Many aircrafts have a propellers. These propellers helps an aircraft to fly. This is linked to torque. And also when the aeroplane turns, torque is applied. And also Newton's third law. Every action has equal and opposite reaction. As we show the example, every action has equal and opposite reaction. And next, let's move on to another experiment. Vacuum cleaner.
In our more thing, the Bernoulli's principle we use in daily life in vacuum cleaner. And in vacuum cleaner, here the low pressure will be created, so it sucks the dust particles. And like this, the Bernoulli's principle will be applied in here. And one more will be applied.
Here, in many railway stations and metro stations, you have seen the yellow line. It indicates the danger because when the train is arriving with a high velocity, if we stand here, it disturbs the existing air in atmosphere and creates an area of low pressure. And if we stand here when train is arriving, it will take us. Train will take us with it, and there will be a loss of life or any disaster. So, Bernoulli's principle is may become danger or anything. And sir, please. Sir,
And also, we have used all these material in low pressure.